All right, for this video, our learning target is to understand the properties that describe solutions in terms of concentration, solutes, and solvent. Our success criteria are to determine whether a solution is an electrolyte or a non-electrolyte. Identify factors that affect the rate of dissolving. To analyze solubility curves. And finally, to explain the differences between saturated, unsaturated, and supersaturated solutions. So if you look right here, all right, here are three different solutions, and what we've done here is there is some sort of a battery down here that you can't see, right down here somewhere, and we have the different leads that are coming through the battery, the positive, the negative. We're hooking it onto this light bulb and then hooking it back in there. So basically, I have two different leads here in this liquid. And if this light bulb lights up, then that liquid would be able to conduct the electricity through it. Okay? So since this light bulb right here is not lit up, that would be a non-electrolyte. If you look at this one, it's lit up, and so is this one right here. That one's a little bit dimmer than this one. So this one would be a stronger electrolyte than that one would be. Okay, so this is a weak electrolyte, this is a strong electrolyte, and that's just the ability for this current to move through the liquids. Okay? So if we had a bulb and harness set like this, we could test out whether something was an electrolyte or a non-electrolyte. So what are some factors that affect the rate at which something will dissolve? Well, first of all, if we increase the surface area. Well, how are we going to increase the surface area? We're going to make it smaller. So think about it like this. If I have a sugar cube and I throw it into a glass of water, or if I take that sugar cube and smash it all up and then throw it into the glass of water, which one's going to dissolve faster? The smushed up one, because it has a greater surface area than the cube does. Okay? So if you increase the surface area, you will increase the rate at which it dissolves. Okay? If you agitate or if you stir a solution, okay? If I have coffee and I put one of those little pink packets in it in the morning, I stir that packet up. I stir that coffee to help dissolve that little pink into the coffee. Finally, I could heat the solvent. Okay? If we heat something, we've learned based on the kinetic molecular theory, if we heat something, those molecules are moving faster, correct? If those molecules are moving faster, it's going to cause the quicker rate of dissolving. So those three things, increasing the surface area, agitate the solution, or heat the solvent, all of those will increase the rate at which something dissolves. Now, we'll talk a little bit about this increasing the surface area here. So if I look right here, I have two different boxes. Okay? I have two different boxes here. I have the small one right here, and I have a bigger one right here. So if I look at this, each one of these sides are 1 centimeter. So I have 1 centimeter cubed for my volume, and my surface area is going to be 6. Okay? Because right here, 1 times 1 is 1. And how many sides do I have on that cube? 6 sides on the cube, right? So my volume is going to be 1 centimeter cubed. My surface is going to be 6 centimeters squared. Now, if you look at this one, okay, here's one. This cube has 2 centimeters by 2 centimeters. Well, what's 2 by 2? 4 times 2 is 8 for my volume. Okay? So if each side is 8, and I have 6 sides, then I'm going to have 24 right here. Actually, that's not true because each one's going to be 4. Each one's going to be 4 times 6 is 24. Now, the whole idea with this is to look at this ratio. If I divide 6 by 1, I get 6, correct? So my surface to volume ratio is 6. What if I divide 24 by 8? What's that? That's the 3 to 1. Okay? So 6 to 1 is bigger than 3 to 1, correct? So my surface to volume ratio is bigger on the smaller cube than it is on the bigger cube. All right? Why does the smaller one dissolve faster? Well, because it has more contact with the solvent. Let's say this is a cube of sugar. The water can get to the more of this sugar on the smaller cube than it can on the bigger cube. And think of it like this. In the middle of this cube right here, will it ever get touched by the water? Well, not until the outside dissolves, right? So it's going to take a little bit longer to get to the middle there than it does to get to the middle here. Does that make sense? Agitating the solution. Okay? A or B? A or B? Which one's going to dissolve faster? Well, obviously A is. Why? By stirring that, what are you doing? You're moving those molecules around, aren't you? And if those water molecules are moving around, aren't there going to be more contacts with the salt or the sugar cube than if they're not moving at all? Absolutely. Okay? So making those more contacts by stirring it will help it to dissolve faster. Heating the solvent. Right here is one of the solubility curves that we will use. I believe I got this one off of WebAssign. Now, if you look at these, okay, the solid lines are solids. The dashed lines are gases. All right, and right here, grams of solute per 100 grams of water. So this is the amount of solute per 100 grams of water. Down here is the temperature. Now, of the solid lines, aren't most of them going up as my temperature increases? Okay, I can only see this one right here. Okay, looks like sodium sulfate. That one is going down. Okay, but all of the other ones are increasing. Maybe not by much, but they are indeed increasing. Now, if you look at the gases, the dotted lines, those are decreasing, correct? So if I have a gas, the more temperature, the less I can dissolve. But if I have a solid, usually the greater amount of temperature, I can dissolve more of the solute in that. Now let's talk a little bit about solubility. Okay? Solubility. The amount of a substance required to form a saturated solution with a specific amount of solvent at a specified temperature. So when we're talking about solubility, we need to have 3 things. Okay, we need to have 3 things. We need to have a temperature, right here, 20 degrees Celsius. We need to have how many grams of the solute? 87 grams of sodium nitrate. And we need to know how much of the solvent we have. 100 grams of water. So we need those 3 things. So this is telling me at 20 degrees Celsius, I can dissolve 87 grams of sodium nitrate in 100 grams of water. So those three things are necessary for my solubility. Now, a saturated solution is a solution that contains the maximum amount of dissolved solute. So, if I would go back to here and say, all right, here is the maximum amount of solute, 87 grams, that I can dissolve in 100 grams of water at 20 degrees Celsius. That would be my saturated solution. That's the most I can dissolve at that temperature with that amount of water. So that would be saturated, okay? Right here's another one. At 20 degrees Celsius, I can dissolve 35.9 grams of sodium chloride in 100 grams of water. Now, what would happen if I would say, okay, I've got 200 grams of water? How much could I dissolve? I would double that, right? 35.9 times 2. What if I would only have 25 grams of water? What would I do to that 35.9? Divided by 4. Okay? So we can actually do that, and you will need to do that actually when you're doing some of these web assigns looking at solubility curves. An unsaturated solution. An unsaturated solution is a solution that contains less solute than a saturated solution under the existing conditions. So, we just said that we could have, what, 35.9 of sodium chloride per 100 grams of water at 20 degrees Celsius. Well, here, we've only got 25.9, okay? I've only got 25.9 grams right here. So, I could dissolve how much more in there? 10 grams, right? So this would be an unsaturated solution because I could still dissolve more into that particular solution. Now, a supersaturated solution is a solution that contains more dissolved solute than a saturated solution contains under the same conditions. Now, that might not make sense to you because we said, well, if it's saturated, it contains as much as it possibly can hold. However, now I'm telling you that a supersaturated solution could hold more. Well, the reason for that, folks, is we've played a little bit with our conditions, okay? We stated that if we have a higher temperature, we can typically dissolve more, correct? Now, when I'm making a supersaturated solution, I get to one of those higher temperatures, I dissolve so much for that temperature, and then I just let it cool on its own. So I've got this much dissolved in this temperature, then it cools down, it actually can hold more than what it should be able to at that temperature. Okay, that's what we called supersaturated. A supersaturated solution may remain unchanged for a long time if it is not disturbed. But once crystals start to form, the process continues until we have the equilibrium reestablished at the lower temperature. Now, what that means, okay? I could take, let's say I'm dealing with salt. I've got salt supersaturated. I could take one little crystal of salt and throw it into that supersaturated solution. That would disrupt the equilibrium that it has there, and it would cause all of the extra that I have dissolved in there to come out of that solution. Okay, it would cause all of that extra to come out of that solution. Okay? So, if you look at this for sodium chloride, all right, at 100 degrees Celsius, I can dissolve 39.2 grams in 100 grams of water. So let's say I dissolve that 39.2 grams in there. Okay. Then I let it cool down to 20 degrees Celsius. Well, at 20 degrees Celsius, I should only be able to have 35.9 grams in there. So I've got an extra, what, a little under 4, excuse me, a little under 4 grams extra that should not be able to be dissolved in that. So what would happen if I would throw in that one seed crystal? If I'd throw just that one crystal in, it would cause all that extra to come out of the solution, and I would only have the 35 grams in there. Now, right now, we're going to show you this video here. Okay. Now, look at this. One thing, okay? This guy's got chemicals in his hand. Does he have any goggles on? Wrong. Right? We can't have chemicals without goggles on. See, all the crystals that were extra are coming out of solution now.
It does look kind of weird. It's so cool. It's real. They look like feathers. Can we touch it? Are we gonna wait till it's all crystal? Either way, it's such radioactive thing. Oh my gosh, frosty. You can't see like that. See that stuff?
So that is the supersaturated solution. They added the one seed crystal in there, and you can see that all of the extra crystals that were dissolved in that liquid have now came out of the solution. Okay? They've now came out of the solution.